To conclude this series, what we're going to do now is interact with the program at runtime. So that means we will assign values to variables from the keyboard. Okay? So while the program is running, we can give a value to an integer or a float or to an array, and then be able to retrieve it with a printf statement. So we're going to need a new function called scanf. And scanf is part of the library. It's within the library file stdio.h, just like printf. So let's get started. So let's say I have a variable int a, okay, and I want to assign its value while the program is running. Now, if we want to assign its value at what we call compile time, the way to do it is you would do something like this. Okay, so this will be called a compile time assignment. And then you can print its content here, a equals, and then %d/n, and that would be a here. This is what we call compile time assignment, which means it's in the code itself, right? So you compile and run this, and you're going to get your 7. That 7 was assigned at compile time. We want to assign a value at runtime, which means we want to interact with this from the console, right, while the program is running, and decide at that time to enter a value. So it's not written in the code, right? It's not initialized. It is something that will depend on what we want to enter while the program is running. So let's change this line here by using the scanf function. But since you want to write the program interactively, you're better off have a printf statement that says enter a value. Let's suppose you didn't. Let's say we go ahead and use the scanf function. Here's how you use the scanf function. It takes 2 parameters. One will be a string literal that is based on the data type that you're going to be using. And since it's an integer, %d. Next, you put a comma here. That's the second element within the parameter list here. And that will be the address of a. Where do you store this value that you want from the keyboard? I want it at, remember the addresses, and %a. So you're always right here, you're going to put an address, not a, but an address. Okay? And let's see how this works. Now watch this. I compile and run. And notice my program is simply blinking here. This is why I said you're better off writing a printf statement right before this. So if you're running this, people are not confused as to what's going on. But we know it's waiting right here at the prompt that I enter a value. Let's enter 3. And a equal 3. Now, to make it a little easier, as I said, do a printf statement here and ask for a value. Enter a value for a. And then you can do this. And let's go ahead and do compile and run. And this is a little better. And notice where the prompt is, right next to that, right? And then you can enter whatever value you want, -3. Well, let's see how that works. A is equal to -3. Okay? So scanf. Now, let's go ahead and use it with a float type. So float b. And so enter a value for a. B, we're going to be asking, again, to enter a value for, so we're going to do a printf statement here. Printf. Enter a value for b. Now we know that b is going to be a float type, so we have to be really careful how we do our scanf, and watch how you do it. So the scanf for that one, notice printf, scanf, printf, scanf, if you want to do it interactive this way. So scanf for b, and notice since it's a float, you're going to write %f. Now, one big mistake I see a lot with some students is they try to format it here. Don't do a %point, 1f or 2f. Don't do any of that. Just %f. Okay, comma. Nothing changed. And %b. You're storing this in b. Now we could see what the result is. So printf. Now you could set up the precision any way you want for a float number. And that would be equal to, let's say %.2f, which means I want it at 2 decimal point. That's great. When you're outputting, you could do whatever you want. And that would be the variable b, right? So b. All right, well, let's see how this behaves. Let's compile and run. And sure enough, it's asking me for a. Fine. So notice how your program is sequential, starting from the top down, right? So we're going to enter 23. And for b, minus 6.34. And let's see if we get those values. And sure enough, everything adapts nicely. Now, how about an array? Okay, can we enter data into an array? It depends. What kind of array do you want? Do you want an array of floats, of integers, of characters? So you have to decide how do you want that. So let's simply have an integer array. Let's call it AR and give it a size of 3 elements, right? So there you go. And what we're going to do now is I'm going to write here, so I'm going to printf data entry for the array AR /n. Okay, and then we're going to do scanf. Before you do that, so maybe something like this: printf AR 0 equals. Then don't do a /n here, so your prompt will be right next to it. Watch this. Scanf. Now remember, you're storing integers in each array member. So that would be %d. And then you have to be specific. Where are you storing this? And %AR 0 using the index. Let's move on to the next one. Printf AR 1 equals. So this is a message that will appear, and then we're going to interact with the keyboard and store it in the next element within the array, %d, and that would be and %AR 1, right? And then the last element will be this, printf, and enter so we know what we're trying to do here. Data entry, and we're trying to do %d here. Oh, sorry about that. We're not doing a scanf here. Lost track. So AR 2. Remember, it's always size -1 for the last element equals. And we'll do a scanf for that one. Scanf. And here you're going to put %d, comma, and that would be n %AR 2, the last element. Okay? So now we'll be able, can we print the elements of the array? Yeah. Let me go ahead and print them all in one line. Printf. And content of the array. And let's do this. %d /t, %d /t, %d /n. So what I'm doing here is I'm going to print all of the elements in one line and then give me a new hard return before I hit the press any key to continue here. So here I'm going to write for all of these placeholders, okay, I'm going to go to AR 0. The first one, that's the first placeholder. The next one is AR 1. Now, there are better ways to handle arrays than this, but it shows you can do this all in one print statement. AR 2. Okay, so now close the parentheses, semicolon. Let's make sure this compiles Okay, good. It compiles nicely. Let's go ahead and run it. So run. And notice it's asking me to enter a value for A. Well, let's go ahead and do that, 12. A value for B, 1.2, 2. Okay, that's fine. All right, so we've got that. Now the data entry for the array AR. AR 0, okay, I want to put a 9 there. This one I'll put a -1. Now remember, these are integers. Okay, and I want to put a 0 in this one. Let's see what happens. Fantastic. So you get your 9, -1, and 0. And let me spell content better. So here you go. I have an extra E there. Now, could I use a pointer so let's go ahead and let's have fun. Use a pointer to print the content of the array. Well, first you need to do is assign a pointer to the beginning of the array, right? So how do we do that? Well, we know that the data contained in the array is of integer type. So your pointer has to be of integer type. So it has to match the payload of your data structure. So int, let's call it PTR, and make it equal to AR. So we know that will be the beginning. So go ahead and print the first element, printf. And we're going to do this. Content of the array using a pointer. And I am simply going to do this. Watch this. And I'm going to printf the first one. And that would be a %d. The first one. What do you think I'm going to do? Asterisk PTR. That's the first one. Then do what with the pointer? Increment it. And then do what? Printf. And I'm going to do this. /t, so I'm going to move it by a tab. %d. Because I'm on the same line. I want to simulate the same effect we did with the one using the index. And that would be comma $PTR. Okay. All right. Well, how about we move on to the next one? Right. And that would be the last part. PTR plus plus. Oh, don't forget to put a semicolon after PTR plus plus. Otherwise, you're going to get a syntax error. Right. So semicolons. Printf. And now again /t for the first one. I mean the last one, %d, and then a /n. And then dereference the pointer, $PTR. Now let's see how this behaves. Okay, so let's compile and run. Okay, so it's asking me for a value for A. That's fine. 2. It's asking me for a value for B, -0.44. Now it's asking me for data entry to the array. And I'm going to put a 2 here. Next one is a 5. And the next one is a -1. Okay? And notice that we get the same results that we did with arrays or pointers. Okay? All right, fantastic. So the next set of lessons will take us, let me see here, into functions.